This is, of course, the periodic table of the elements, and our lecture today is on ions. Do you guys remember what the definition of an ion is? Yeah, Tiva says it's an element that has either lost or gained an electron, or it is, I'm going to call it a species because it's not just an element with a charge, because if you lose or gain an electron, you have a charge, and the charge is the important functional thing here. If you have a charge, you are an ion. And if you are an ion, you have a charge. That's just the definition of an ion. So positive charge if you have fewer electrons than might be expected. Negative charge if you have more electrons than might be expected. And we have lots of different kinds of ions. Actually, we have 3 different kinds of ions. And the first kind of ion that I want you to know about is the elemental ion, which is exactly what you were saying, Tiba, which is where your element loses or gains an electron. And for the moment, we're going to focus on main group ions. So the main group consists of the S block and the P block here. So just these elements. So main group ions are interesting because they lose and gain electrons in predictable ways. So what does that mean? Well, that means that we can just look at the periodic table and predict, based on where you are in the periodic table, what kind of ion you're going to make, right? And Tiba mentions we can lose or gain electrons, and Erica notes that there is such thing as a cation and an anion. So let's clarify that right here. We do have 2 different kinds of ions. We have cations and anions. Cations have a positive charge. Oh, that's a positive sign. And anions have a negative charge. So cations have lost electrons and anions have gained electrons. And here's how I remember it. There's lots of different ways you can remember that cats have pos. So cations have a positive charge. Or I just remember that the word cation itself has a positive in it. That T in cation looks like a plus sign. So that's how I remember that cations have the positive charge and anions have the negative charge. But you will remember back from our discussion on the periodic table that you can just look at the periodic table and tell how many valence electrons something has, right, in the main group elements. And so if I asked you this, in fact, this was an exam question, I hope you all got it right. If I said, how many valence electrons does sodium have, what would you tell me? One. Perfect. So sodium has 1 valence electron, like everything else in this group. What about magnesium? Like everything else in that group, magnesium has how many valence electrons? 2. Perfect. What about, again, we're going to skip these transition metals. Anything in group 3, aluminum, how many valence electrons does it have? Excellent. And carbon? 4. And phosphorus? And everything else in that group? 5. Okay. You got this. All right. And what about everything in this group here? 6. Whoops. That's supposed to be a 6. All right. Put that into position. Excellent. What about fluorine? 7. Excellent. And everything in this last group here? 8, with the exception of helium, which only has 2, right? Okay. Now, everything, all the electrons fill in the same order, so they have the same electron configuration if they have the same number of electrons. And we find that the noble gases are stable and non-reactive because they have full shells. There's something really special about having a full shell. So what we find is that all of these main group elements will either gain or lose electrons to try to get the same number of electrons as the closest noble gas. So for fluorine, what do you think that he would want to do to become just like the closest noble gas, which is neon right next door? What does he need? He needs one more electron, right? Right now he's got 9. If he had 10, he'd be just like neon. So he wants to gain an electron. If he gains 1 electron, what will his charge be? -1. Perfect. And you can hopefully see that chlorine and bromine and iodine and astatine are in the same boat. Chlorine will want to gain 1 electron to be like argon. Bromine will want to gain 1 electron to become like krypton. Iodine gains 1 electron to become like xenon. All of these, when they make an ion, if they make an ion, they make an ion with a charge of -1. Does that make sense? And then, of course, the noble gases are 0. They make a 0 charge. Okay, so everything in group 7 wants to gain 1 electron. And so when they form ionic compounds, when they form ions, they make a -1 ion charge. Okay, what about everything here in group 6? What can you expect from that? A -2, right? Oxygen has 8. He needs 10 to be like neon. So, that's going to gain 2 electrons. That gives it a -2 charge because electrons have negative charges. Okay, what about nitrogen? -3 for the exact same reasons, right? I'm at 7. I'm a little bit further away from that noble gas, so it's going to take me more electrons to get there. But if I gain 3, I'll have 10. And I'll be just like neon, so I'm going to have a -3 charge if and when I make an elemental ion. Okay, now let's go back here and let's look at this first group. What about lithium? What do you think lithium would like to do to become like the closest noble gas? I mean, it looks, if you're looking at this flat table, it looks like the closest noble gas is neon. But Tiba is right. This kind of circles around, right? Because it repeats, and 2 is much closer to 3 than 10 is. So if I just lose 1 electron, then I'll have 2 electrons just like helium, and I'll have a full shell. I mean, I'll have emptied that level 2 shell, and now I'll have a full level 1 shell. So everything in this first group would like to lose its 1 electron to empty the shell that it's in and to get back to the most recent full shell. So everything in this first group then, because they lose electrons, is going to have a +1 charge when they form ions. And in fact, this is extremely favorable. It's why these are so highly reactive. You will never find them in nature as elements because they will have already reacted. They'll have already given away that electron. All right, what about everything in group 2? Magnesium, for instance. How is he going to get to be like the closest noble gas? Nicole says he gets a +2 charge. That's right. If I remove 2 electrons from 12, I'm going to have 10, just like neon. Fancy that. That's pretty cool. Okay, what about boron here? What might boron do? Now he's at 5, right? And the closest noble gas is the one that came before, has 2 electrons, and the one that comes afterwards has 10 electrons. So he can either lose 3 electrons to be like helium or gain 5 electrons to be like neon. And it's easier to manage 3 electrons than 5. So he's going to lose 3. So everything in this group, if and when it makes it an ion with the charge is going to be +3. All right, and then carbon and silicon, this group here in the middle, it doesn't actually usually make ionic compounds because 4 electrons is a lot to lose or gain. Usually makes a different type of compound that we'll see in the next chapter. But if it did, it would make either plus or minus 4. Okay, excellent. So if I'm looking at your worksheet here, the first thing that we do after this part of the lecture is we come along and we say, if I give you an element, can you tell me how many valence electrons they have and tell me what kind of charge that they're going to make, right? So let's just do this for a few of these to make sure we're all on the same page. If I'm looking at K, the element represented by K, How many valence electrons does it have, and what charge will it make if it makes an ion? Perfect. Sarah and David say that it has 1 valence electron, and it will make a +1 charge, or just a plus is also appropriate because it's right here in this first column. So you can just look at the column and you'll know what the valence electrons and the charge is going to be. Okay, what about this one right here, Si? It's right here, so it's got 4, and it would be plus or minus 4. Yeah, that's right. Excellent. What about Ba right here? David's right, it's got a +2 because it's in this column, 2 valence electrons +2 charge. What is it, Erica? Oh, no. So Erica says even though the K gains 7, it only has a plus charge. No. Everything in these 3 columns does not gain electrons. They lose electrons. That's why they have positive charges. So the potassium, we predict, it could either gain 7 to be like krypton, or it could lose just 1 to be like argon, right? Because K has 19 electrons. Argon has 18 electrons. So if it just loses 1, it'll be like argon. So you could almost take this periodic table, of all of the strange variations on the periodic table that I've seen, the one that I've liked the most is where they take the periodic table and they cut it off here, and they cut it off here, and they wrap it around to make like a circle, like a column, so that your sodium ends up coming right after your neon. And it just kind of, does that make sense in terms of the column? I'm glad you asked that question, Erica, because it's simple to do, but it's also easy to forget. And I'm sure that you're not the only one in this class who may have done that, right? So you get this column and it just wraps around, and you go from neon to sodium, and they're right next to each other, right? Because neon is 10 and sodium's 11. And then it's easier to see that you're going to step back, right? Because they're right next to one another. When you lay it flat, then it looks like they're nowhere near each other, right? Kind of like your standard map of the world that makes it look like when whatever's on the left-hand side of the map is nowhere near the right-hand side of the map, but really they're right next to each other. Okay, good question. I'm glad that you brought that up. Okay, what about, let's skip ahead. What about chlorine here? All right, Sarah tells us it's got 7 valence electrons because it's in group 7, and it'll have a -1 charge because it gains 1 electron. Perfect. All right. You guys feel good about that? Can give you a question like that on the upcoming exam too. Yes, okay. Just make sure you don't overthink it. Okay. All right, so that is our introduction to ions and our introduction to main group ions particularly. Now, those are not the only kind of ions there are. There's 2 other kinds that we need to know. And the first is that we're going to talk about is polyatomic ions. So polyatomic ions, if you can tell from the way that word is structured, polyatomic ions are ions, which means they have charges, but they're on not a single atom like our chlorine atom, but they're on a cluster of atoms. So polyatomic ions are clusters of atoms with a charge, because of course if they're ions, they have to have a charge. Now, the way those clusters of atoms are held together is with covalent bonds, which we haven't covered yet. We're going to cover it on the next chapter. So at this moment, instead of worrying about how they're held together and why there's this cluster of atoms with a charge, I just need you to know that this cluster of atoms stays together, and overall they have a charge, and they're predictable. And there are 20 of these that I want you to memorize for the test. And the reason that I have you memorize these is because you'll see these in common use, right? So I would never have you memorize something that wouldn't actually be useful at some point in time. And of course, because I'm having you memorize them, I'm going to use them throughout the semester. So you'll want you'll want to have these memorized. So here's the name of the polyatomic ion and the formula for that polyatomic ion, and then there's a charge. So you need to know the name, the formula, and the charge. So hopefully you see we have these clusters, right? So the hydronium ion is a cluster of atoms that includes 3 hydrogen atoms and an oxygen atom. So we're going to do a little formula just like we do for compounds. But then they have a little charge, because if there's a charge, I have to show it. It's up here in the upper right-hand corner, all right? And some of these you may have seen before. If you haven't seen them before, it's because you haven't been paying attention, because I guarantee you've seen them before. And I want you to start paying attention, right? And post on the discussion forums if there are any you recognize, if there are any you start to see. But for instance, you'll see ammonium and nitrate and phosphate and sulfate. All of those you'll see in fertilizers. In fact, it was ammonium nitrate that was the stored fertilizer that caused the explosion in Lebanon in August, which, holy cow, I mean, that was catastrophic and only 6 weeks ago, but I couldn't even remember when that happened because 2020, right? Carbonate, hydrogen carbonate, these are in baking powder and in baking soda. And also you'll see hydrogen carbonate as a buffer in your blood. Cyanide, everybody might remember that as poison that you might have read about in a mystery novel, for instance. Oh, good question. Zachary says, how come some don't have a charge? No, they do. They all have a charge. You might not be able to see it clearly unless I'm zooming in here, but there is definitely a charge. The nitrate has a negative charge right here. Nitrite has a negative charge right here. They're kind of small on your screen. You may not be able to see them very clearly. Now, I just copied this from my lecture notes, so you can also see them there. But they all have charges. In fact, you'll notice that almost all of them have negative charges. Oh, that's terrible. 3 minus. You don't have to memorize how to spell them for the exams, because this is a great question, Erica. Do I have to memorize how to spell them? You don't have to memorize how to spell them because the exams are multiple choice. But the Master in Chemistry will dock you if you spell it wrong. So make sure that you've got the spellings right. And note that some of them look really similar, right? Nitrate and nitrite, keeping those two straight. And same thing with sulfate and sulfite, keeping those two straight. Some things that might be helpful, just because otherwise it just feels like you're brute force memorizing them, and I totally get that, is you'll note that some of these with a 2- charge might have an analog that has a hydrogen in the front and then a 1- charge. Now that is expected because, as you remember, hydrogen ions have a +1 charge. So if I put a +1 charge with a 2- charge, then I'll be left with a 1- charge. So carbonate, if you can remember carbonate, then you should be able to figure out hydrogen carbonate, right? And you don't just have to memorize those two because they're related. Same thing for phosphate and hydrogen phosphate and dihydrogen phosphate. Phosphate having a 3- charge. If I add a hydrogen to make it hydrogen phosphate, now it's got a 2- charge. If I add 2 hydrogens to make it dihydrogen phosphate, then it'll only have a 1- charge. And same thing for sulfate and hydrogen sulfate. All right. Nitrates often used in cured meats, and it is what some people think causes the cancer that you get if you eat a lot of cured meats like hot dogs and salami. And so you'll start to see in the grocery stores salami or hot dogs that say no nitrates, and so on and so forth. So you'll see these, especially if you start looking at them for them, you'll really see them a lot more, but you do need to have them all memorized, name, formula, and charge. Any questions on that? Nope. Okay. So just going back to your worksheet again, because this is what we usually do, is we'll do a little bit of lecture and then a little bit of worksheet work to show you kind of what I'm going to expect from you. And as you can see, if I gave you the name, I'd like you to be able to tell me the formula charge. If I give you the formula, I'd like you to tell me the charge. So let's just practice this, just looking at this table for a minute. Can we find the hydroxide ion? What does it look like? Perfect, Sarah. It has an O and an H and then a negative charge. I'm not going to make that a superscript because I can't do that here in paint. Okay, what about the oxalate here? By the way, hydroxide is super basic. It's the main component in something like your Drano or your lye solution. Very damaging to the skin. You wouldn't want to spill it on yourself. Good. Oxalate C2O4 with a, watch out there, Sarah, it's a 2 minus. C2O4 with a 2 minus charge. And oxalate can be one of the principal components in kidney stones. So if you've ever experienced a kidney stone, you know what to blame that on. All right, what about NO3 minus? What polyatomic ion is that? Good, that's the nitrate. Excellent. And the OCl minus? Some people might draw it as ClO minus, but it's the same thing. It's hypochlorite. Okay, good. Any questions on what I expect you to do here? This is the place for flashcards. They don't work well for everybody, but it's once you get it in there, then you can start making the connections that make it easy to remember them. Just memorizing them. I mean, we're going to work with them. We don't stop at memorizing them, but yes, you need to memorize them. Okay. That's it for this lecture. We'll pick up next time with forming ionic compounds.